shape of whatever container it's in, and it moves freely with difference in potential or pressure. So, of course, we have two types of fluid. When we get into power, there's a lot of things that could be considered slurry. Slurry could be considered, and pneumatics. Of course, we're predominantly pneumatic in this room. In fact, that's all we have, by the way, is pneumatics. But in industry, you'll probably run into both of them somewhere. So it has no fluid, it has no fixed shape. Takes the shape of whatever it's in, right? So air has no fixed shape. So air is a fluid, right? And it moves easily with differential pressure because we have difference of potential air or wind blowing all the time, right? Very seldom. So fluid power systems, hydraulics creates pressures with liquids, usually oils, but you could use water. Water. You could use. In fact, some people do use oil, but they'll put lubricants in it because water is very, very corrosive on metals, right? So it's uncompressible. We consider it to be uncompressible. We could not measure it. So that means if we had a cylinder and we put something in there and we tried to push down on it, you couldn't because you cannot compress. We can't compress it. Allows extremely high pressures. Allows very smooth motion. Allows precise speed control of actuators. Compared to pneumatics, the actuators can be a lot smaller to create the same amount of force. And it's efficient to operate. Biggest problem we have is most of the time the hydraulic fluid is going to be oil. And what advantage does that oil have in there over other liquids? Hydraulic fluid is usually oil. Helps lubricate the system. So your brake fluid is an oil. Right? Higher degree of risk, so it's more dangerous if it springs risk. In fact, I've heard of people get a hairline. Most of the shots that we got in the service, we would get in boot camp. We got our shot card up to things. Was that they had these two metal lines, and we'd walk through there, and they would shoot us with the syringe guns, and no needles. I mean, that'll be on both sides. And shoot it with. So if it's high enough pressure and you shoot it at a small little stream, it'll go into you just like a needle. The problem is that most hydraulic fluids are very dangerous, and if you get them in your skin, it's going to cause some major problems. They show one where a guy actually lost part of his arm, had to cut it off because he got a hydraulic fluid in it. Expensive to install and maintain. Then we have pneumatics. So we create pressure with gases, usually air, must be compressed before we can use it. It's cheaper to install than hydraulics. It's a lot safer pressure because we don't require return lines. It's inefficient to operate. It releases moisture when it's compressed, so we got to have something to get rid of the moisture in our system. Jerky motion, and it's very difficult to precisely control the speed of an actuator. You can get it okay. So if speed is not extremely critical, then pneumatics works fine. So the components of a hydraulic system, we're going to have a reservoir. Most people call that a tank. We're going to have a pump. We're going to have piping. We're going to have at least two lines. We're going to have a pressure line and then a return line that brings it back to the tank. We're going to have pressure regulators most of the time, directional control valves, and then actuator. Now, actuator is the term we use for any device that takes pressure and converts it into motion. Pneumatics, we have a compressor. We have a tank. My corrections didn't get made. We have a tank, which technically it's called a receiver. We have piping. It's usually plastic. Metals, it can be aluminum, which is a lot cheaper. We're going to have control, and we're going to have actuators, pressure regulators, and directional control valves. So my latest update is not up here, guys. Dang it. see if I can. So force is equal to the amount of area that you're pushing the pressure against. So you can't have force without pressure, and you can't have pressure without force. So force, what is force? So is pressure and force the same thing? So can I have pressure without force? Sure. I can go over and push against that wall, and I have pressure, but I don't have force. So to get a force, you got to think something has got to move. Something's got to change directions or move. So pressure is just it's a difference in potential. So this would be like current. We can have a difference in potential without current, right? You understand? But we can't have current without a difference in potential. So we can't have force without pressure. But we can have pressure without a force because, if we're pushed against a wall, if you're real strong, you might cause it to move. But you got to have motion to actually do work or generate force. So nothing's 100% efficiency. So we have pressure. So our fluids so what our fluids are going to do is they're going to generate a pressure. And then we're going to have to push that pressure against something to create a force, right? Which just causes the actuators to move. That makes sense? Okay. And then, of course, nothing's 100% efficient. Some of these are really, really pretty efficient, but it's always less than one. So nothing's 100% efficient, guys. So this is where I was at. So this is, we looked at pros and cons. I don't think I've added anything to that, but I did add a little bit to this. So usually plastic or metals. The metals is usually aluminum. We have a pressure line, and then it doesn't require a return on pneumatics if we use air, and that's what you're going to run into out there because air is already here, right? So we can just bend it. So it's a lot cheaper to install. Over here, though, usually uses metals or high pressure tubing, hosing or tubing. We got a pressure, we have to have a return. And then our control, we have a pressure regulator in some type of way to control the flow, and then actuators. So the reservoir, or the tank, just about everybody calls this a tank. So in hydraulics, we got to have a tank. And then, of course, we're going to bring the fluid back and put it into the tank. Usually when it comes through, it'll run through like a strainer or something. And then when we pump it, we'll pump it off the bottom of the tank. Heat exchangers, yes. Anytime we move things or anything, it creates. I don't know if anybody's been in hydraulics, right? And everything's moving. You'll notice the tubing is warm, right? Because we're moving things under pressure. Of course, it acts like a fluid in a conditioner. Let's see. So the reservoirs should hold 2 to 3 times the pump output per minute. Ensure a high enough fluid level that when all the actuators are extended, there's not a whirlpool effect at the pump section. Because if you see a whirlpool, what's it sucking in? Air. And then, of course, air is compressible. Anybody had to have their brakes bled on their car? Of course, you don't see it much anymore, but in the old days, you could tell if you needed to bleed your brakes because you'd have to pump your brakes before they worked. Well, the problem is that it had air in the system, right? You understand that? And you still bleed them. If you ever get new brake fluid lead put in, usually they'll make sure they bleed out, make sure there's no air. Have enough airspace when all the actuators are fully retracted to allow for thermal expansion. So liquids do expand when they heat. So it'd be awful, you get in there a real hot day and your hydraulic fluid starts spilling out. Shape, tall and narrow is preferred over wide and flat. So this is reservoirs usually have oil level indicators. They'll have a filler. They'll have a breather. Anybody ever seen a hard drive, a real hard drive come out of a computer? Have you ever taken one apart? It's got the little breather on there. And what's the purpose of that? Well, when it's not hermetically sealed. Well, it's sealed, but it's got to pull air in and do and then when it heats up, the air's got to get out, right? You understand that? Internal access doors, breathers, baffles, drain plug, temperature gauge, optional, and we usually have to have a filter in there. So this is a typical hydraulic tank. So it's usually got a big access door on it. What's the purpose of this guy? Yeah, maintenance cleans out. You know, it's just like, and then this would be the filler gauge. It's usually just a sight gauge on the side is all I've ever seen. Huh? This? This is the filler gauge. So all it is just a glass. It's just a glass tube on the outside, and when the air fills, when the water, when the I'm sorry, when fluid fills up, you just see it through the sight gauge. There's not very much to it. Hydraulic piping, we gotta have high pressure tubing. So hydraulics, we use extremely high pressures. I think I told y'all maybe the other class is that if you climbed up in the tail of these big airplanes I worked on, and you looked at the hydraulic, you looked at the cylinders, they was only about that big, and yet there's moving control surfaces that were what? Huge. Well, how can I do it? Well, our pumps are 3,000 psi. So if you had 1 square inch of area, we could create 1,000 pounds of pressure or force on those things. So that's the biggest advantage of hydraulics. Is first, you don't have to pressurize it. So the problem we have with pneumatics is it's constantly trying to unpress itself, right? Hydraulics, we don't do that. You know, liquids, they all you got to do is push them up against something, and they automatically do what? Generate pressure. So that means we can control the flow a lot easier. The actuators can be a lot smoother, and the actuators can be smaller for it to create that force, right? You understand that? So the tubing is usually metal, usually steel, by the way, and this is another good reason for oils. And then the high pressure tubing. If you ever had to replace the high pressure hose on your air conditioner, be prepared, because that's a flexible tube. All the tubing is metal except where it does what? Where it has to go to your compressor, which is on your engine, and your engine is constantly moving. I had to replace that one time on mine. So this is the basic makeup of a hydraulic system. We have a pump, we have a pressure regulator, we have control valves, and then we have actuators. We have all types of actuators. We have hydraulic motors that will spin. We have pneumatic motors that we can spin, rotary motors. Then we have linear actuators. We have rotary actuators. We have different types of actuators that we can use. So that's about it. So it's pretty easy to set up. It's pretty dangerous, guys. So if you got leaks, you got to be careful, because if it's under pressure, it could do what? It could cut you. Yeah, hydraulics can cut you. So pretty simple. Anybody got any questions on this? Not much to it, right? Pneumatics. This is my compressor, by the way. I thought it. So this is the rating on pneumatics. Operating noise levels, maximum pressure. So mine will put out about 150 psi. How much air can it deliver? It's called cubic feet per minute, standard cubic feet. And what they found out a long time on compressors is that, you know, the further you go up in amplitude, the compressor can't put out the flow, because the molecules are not, it can't compress them as much, right? Understand? So that standard cubic feet per minute, this is at sea level. So that they had to come up with a standard. So this is how much it can move, how much air it can move. So at 3.8, at 40 psi, it can move 5.1 cubic feet per minute. At 90 psi, it can only move 3.8. Cooling. We have to cool when we compress these things. When you compress air, it's going to heat up on you. So that means normally, especially in big shop compressors, we're going to have some way to cool it down. Another problem we have with gases is that just about all gases, especially air's got a lot of moisture content in it, right? And air can only hold so much per cubic foot. And when you compress it, the cubic feet go down. So what's the moisture going to do? Yeah, moisture is going to release moisture. Plus, when you heat it up, and then all of a sudden you let it cool down, it's going to condense. So, big problem we have with compressors, whether you got one at home or not, is you're constantly fighting liquids, right? So this one's got an automatic drain on it, but for some reason, somehow it's getting liquids into our lines. So some of y'all had that happen, right? So that's the biggest problem we have. So cooling it down, so sometimes we'll have actually coolers on there, which actually chills the air down, causes it to condense, and then they get rid of the liquids that way. So we have different ways. Filters. So we need an intake filter when it pulls the air through, because our air's got a lot of garbage in it, right? After coolers, these could be they work a lot like condensers that you would see on a steel. We had when I was taking a chemistry class, it was actually a steel. But I mean, I wonder what happened to that thing if somebody didn't steal it. But you'd boil the water, and then it would release the steam, and then you'd chill it down, and all the garbage would stay down. That's the way you make distilled water. You basically just distill it. And that we'd run cold water around the jacket to chill it down and cause it to condense, or turn back from a steam into a liquid, which is the way we make alcohol. Anybody that's into that. Of course, the reservoir of the tank. So how much you can hold in reserve would be the size of your reservoir, your tank. Of course, we have a lot of plastic tubing. So all our manufacturing lines uses plastic tubing. Metal tubing, it could be aluminum. It's up to where you work at, what type of tubing they use. Most of the time, to go from the metal tubing to the device itself, they'll have plastic tubing. So both of our lines use plastic tubing. We're running we regulate ours. I don't know what the compressor's rated at. Seems like it's rated. I don't know. I'd have to see what the compressor's running at. So piping, we have a hydraulic system that runs through the plant. You'll probably have your pump for your hydraulics somewhere, and the tank or the receiver for your reservoir for your hydraulics, or your receiver or your tank at a centralized unit, which is what we have here. So our shop compressor, if y'all didn't know it, the building compressor is in. We have the privilege of having it in our closet in there, and it's a dual stage compressor, so we can put out at least, I think it's around 200 psi is what it puts out. So dual stage means you have a big piston, and then it compresses it, and then puts it into if you put it back in the same size piston, it would uncompress. So you can tell multi-stage compressors because the output piston will be smaller, and it's got a big old cooler on it. If y'all hadn't been in there, it's got a radiator on it to cool it down. And then it purges every once in a while. I don't know if y'all hear it hissing in there. So that automatically happens. It's on a timer. And what that does is it's supposed to get the moisture out, but undoubtedly we got a little bit of problem. So this is about a pneumatic system. We have a compressor, which pumps into a receiver. Then we might have secondary air treatment. Ours does. We go into some type of directional control valve, and then output of that would go to our actuators. We don't have any pneumatic motors. We do have a rotary actuator on the Festo line. So it's basically the same. So here's the compressors. Here's the, probably the radiators that cools it down, or aftercoolers. So cylinders, they're given that name even though they might be square in shape. The actual unit that the piston moves in is going to be round. Uh, we like squares; they're easy to put together, and also it's easier to mount stuff on, especially sensors. So we have two types of pistons or cylinders. What we call a single acting cylinder. So these guys, they exhaust themselves. So I don't know if y'all can see it or not, but there's a little old tiny hole right here. So it exhausts itself. So you can tell a single acting cylinder. This has a spring return on it, so our directional control valve, the only thing it does is apply pressure, and then of course the gas escapes. So, and then we turn it off. So we have 3 ports, and it's a 2-position valve. This right here has 5 ports on it, but these are manually operated. So this over here is what we call a double acting cylinder. So what we do is we use our pressure to extend it and also retract it. Of course, this is pneumatics, but it would be exactly the same for a hydraulic cylinder. Exactly the same. So we use what we call, so we got to have something. So this unit that moves, that's moving, and originally it looked like one, but the unit that's moving inside the cylinder, we refer to this as a spool. So on the Amatrol line over there, that we have the spools that we fit in there. And what we do is it's got gaps in it, and we position it, and it literally routes which way the air or the fluid flows. That would be more correct. This would be hydraulic, or it could be pneumatics. Of course, this is definitely pneumatic because you can see they're venting out to air. Are we okay? So this is a single acting cylinder, spring return. So in a single acting cylinder, it actually exhausts itself. And then, of course, you've got to have something. So we use pressure to cause it to extend, and then something else has to bring it back. It could be gravity. So this is a solenoid. We looked at solenoids, right? Everybody understand what a solenoid is? Everybody okay with that? Right? Okay. Any questions on that? So all ours are what we call solenoid activated. So we have a solenoid that's actually moving the spool. So it's a solenoid. We force a rod in on this side. This is what we call a double solenoid directional control valve. What's that? We know, and I don't have my solenoid, but we know when I put electrical current through a wire, it creates a magnetic field, right? Okay. And I showed you my electromagnet. Okay. Well, a solenoid is we have a tube, and then you have a rod running through the tube. In fact, mine is just a drinking straw. And what happens is when you put current through the solenoid, it sucks the thing up in there. But one way it would be pop coming out, and the other way it was coming in. So that's a solenoid. So all it is a linear actuator. That's all it is. It's a linear actuator. Then what we do is we mount contacts on the plunger or the armature, and now we got a relay. So all a relay is technically is a solenoid that controls contacts. So what we're doing here is we're actually using the rod inside the cylinder, so there's actually a spring in here. And then when we energize it, and it's got wire around it, it pushes a rod out and moves the spool in one direction. That makes sense? And then when we de-energize this one and energize this one, then it's going to push the spool in this direction. And what it's doing is lining up these ports. And so this would be a 4-port. It's unusual that the gift keeps working even though it's operating. That's pretty neat. So you can see when it comes in, you can actually see we block it, then we let it come through. Can you see what I'm talking about? And then we actually control the direction. So a double action cylinder, we're going to have 2 solenoids on it, normally. A single action cylinder, since it vents itself, these are going to normally be one solenoid valves. Are we okay? Everybody okay? Huh? Oh yeah, we'll turn the compressor on when we come back and let y'all. I gotta hook it back up though. And we've got single solenoids and we got double acting solenoids. I mean single. These are not solenoids. We can see the cylinders, but we don't have any solenoid actuated directional control valves up there. They're all manually or pneumatic. So this is the makeup of a typical cylinder, pneumatic cylinder. We have a end cap, and then we have the piston, and then we have the barrel, then we have the rod. The rod is actually what does the work, right? That makes sense? Okay. And one of the ratings on them is the stroke. So the stroke of a cylinder is basically how much of that rod can stick out thinking. So if it's got a 6-inch stroke, that means it'll come out. It'll have enough room to come out and stick out 6 inches. And if it's a double acting cylinder, you can actually see here's the threads for this side, and here's the threads for this side. And then we'll have seals. The seals on pneumatic are really neat. They got like symbol. It's kind of like anybody ever seen the piston of a car or something? It just don't have one ring. It's got what? And that's basically the way hydraulic cylinders have to work. They have to have all kinds of special seals in there. And then, of course, we have the piston. Now, in pneumatics, the piston will probably have a magnet on it. And you can actually see it on this one. They're basically the same. And then what we can do is we can mount a Hall effect, or we can mount a magnetic reed switch out there and detect the position. Now, usually we only look for when it's fully extended and fully retracted. For these, it's different on the Ganter train on the Amatro line. I think it's station 7. Some of y'all worked on that when y'all first disassembled it. Are we okay? So we also have what we call rodless cylinders. These transfer the motion in different ways. Sometimes it'll bring a belt out. I don't know if y'all can see it right here. And it rotates in, and then the carriage will be mounted onto that. Ours use magnetics. So the piston is nothing. The piston is nothing but a big old magnet. Big old magnet slug is what it is. Yeah, it's just a real strong magnet. And then the carriage just locks onto that magnet. So ours, the carriage has nothing to do with the inside. And these are the rodless cylinders. Now, what's nice about rodless cylinders over rodded cylinders is that the stroke is limited. The stroke is limited. You can't have a real long stroke on a rod sticking out, right? You understand that? Even your arm, you can hold your arm out for a while. One of the things they did in the service, I forgot what they called it, but if you got so many marks against you, you'd have to go to outside. They exercise you, and they'd make you take your rifle and hold it out like that. And after you say, oh, this is nothing to it, but a few minutes you're going, Argh. So we can't extend our arms real fast, especially if it's got a load on it. What's nice about a rodless cylinder is basically you got unlimited stroke. because it's riding on the actual mount of the cylinder itself. So we got several of these rodless cylinders. Both lines have rodless cylinders on them. We have rotary cylinders. We have one of these on the Festo line that's actually moving the robot that transfers from the output the entry in magazine over to the other side, and that's just a rotary cylinder. We have this guy that actually flips the acrylic blocks if they're in there upside down, and this is all it is. That's all it is to it. It's got what we call a rack and pinion. This is called a pinion gear. This is called a rack. And what you do with these guys is you take a rotary motion and convert them in, or a linear motion and convert it into rotary, or vice versa. Yeah, this is a rack and pinion. Where do we have these? Where do we have these at for years? Cars. This is the way we steered the car. So you turn your steering wheel, and you could actually see it had two things going out there, and it was offset, and you were actually turning the car with that thing. So this is the one that actually flips, and it's also on the Festo line. We have some that's mounted on the side, and then they have an assembly. When this puts up, it turns a rack and pinion and turns that into a rotary motion. So this is over there on the buffer station where it's holding the cylinders while it's waiting on to catch up with the robot. It's linear to rotary. So it's got a rack and pinion in it too. We have 3 of those on the Festo line. Directional control valves. So cylinders, pretty easy to understand. Directional control valves. Identified by the number of positions the valve can be moved through, usually 2 or 3. I've never seen one with more than 3. 2 is very, very standard. The number of ports, we refer to those as ways. We can have a 2-port valve or 2-way, 3-way, and you can see I got that name because that's the ways that the fluid can flow. So you can see how it got that name, but these are just nothing but ports. So you usually have 2, 3, 4, or 5. We have all of those on our lines. How the valve is moved, we can be manual. We don't have any manual of directional control valves on our lines. Our Amtro line makes a manual directional control valve. That's what the Amtro line makes, a manually operated directional control valve. It could be mechanical. For years, like I said, on earth moving equipment, you go out there, they have these big levers that you're actually shifting the valve with, to raise it up and move it and all that kind of stuff. Now you get into new ones, they got a what? They got a little joystick, so they're using solenoid controlled, pilot control. Pilot control means you're using the pressure that you're controlling to move the spool. Then we have solenoid pilot, which you'll see that a lot in hydraulics. You deal with 3,000 psi worth of pressure, and you got a directional control valve trying to push the solenoid. The solenoids would be real big. So we'll look at this one. We got a real good drawing. In fact, over in the fluid power class, we used to have one of these guys out there. And spring return. So we spring return. So nomenclature. This is so the ways. So if I've got a 5-port valve, that would be a 5 ways. So you'd say 2 position, 5 ports, but that's not the way we say it. What we do is we start off with the number of ways. So I'd say 5, then I'd say 2, and then I say way. Now how that went about, I don't know, but that's the nomenclature. So a 5-port 2-position valve, we'd call it a 5 2-way valve. That's the way you'd order it. A lot of times to confuse, they'll write it out, but that's the way we read it. We start off with the ports. Then the way we write them down is we put a slash between there. So ways, position, then we say way, valve, and then we tell you how it's operated. So ours, we would say like a five two-way valve solenoid operated, or solenoid pilot. Festo uses a lot of solenoid pilot. Its valves are a lot smaller. When we draw the valve, we draw it in its reset or power off position. So that would be the way we would draw it on all the lines back there. That's where they'd be drawn when we draw the diagram. We okay? We're okay. So this would be a two position. I'm sorry, this would be a three position. It's got a center position. This is pneumatics. By the way, in pneumatics, a lot of times, I'm sorry, this would be hydraulics. In pneumatics, we number the ports. Your power ports are going to be your power ports that's controlling the power to coming in is going to be odd numbers. The working ports are going to be even numbers. The ones that actually go to the actuators. On hydraulics, a lot of times we'll call the pressure port, we'll call it P. The one that goes back to the tank, they call it what? T. And then your two working ports, these are the ones that's actually going out to the actuator, would be referred to as AB. What you mean? No, it's three position, four ports. One in the center, so it's in one position. So it's here, 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 here. Yeah. So you can see it on the symbol. So we call this a closed center. So closed centers, this is used a lot in pneumatics because what this does is it locks the actuator in position because the fluid can't move. It can't exhaust and it doesn't come in, right? So the actuator locks in position and we block off the compressor. A lot of times on hydraulics, we'll do this. That way, if the hydraulic pump is not needed to create pet pressure, we just send it back to tank. But we'll never, ever do that on pneumatics. So this is called a closed center. So what that means is, and don't pay any attention to the check valve, if we move it into, so I got my actuator up here. So let's say we got a double acted cylinder. This goes here and this goes here. Now this will work real well on hydraulics. It doesn't work that well on pneumatics. And when I put that sucker in the center position, that actuator will not move. Because why? There's no place for the fluid to go. So these closed centers, this would be what we'd use in hydraulics if I wanted to like stop the actuator somewhere in the center. I didn't want it to go its full stroke. So over there on the Festo line or the Amatro line, we can stop that actuator on the right hand side, that rodless actuator. We can stop it into we can stop it in 4 different positions, and it stops. Well, because it's using it's simulating a closed center. By the way, it's a little different. It's doing this is what's on the gripper on the Festo line. So that means if that gripper's open, you can't close it with your hands because there's nowhere for the air to go, right? Y'all understand that? Or if it's closed, you can't do you can't open it. You can move it a little bit because it's pneumatics. If it was hydraulics, you couldn't do that. We could stop a hydraulic cylinder anywhere, and using this closed center, and you could not move that piston. It would not move. So that's the 3 positions. So can y'all say so center, it blocks both ports. So when it's in the center position, it's blocking both ports, and it can't the fluid can't move anywhere. That okay, Mario? You understand that? Yeah. So we call it a closed center. It's just like when you close a valve off. There's no way it can go. Like I said, this would be what we want. We'd use one of these for pneumatics, because we don't want it to go back to air, right? Because we want a constant pressure. This would be a good hydraulics. I'm sorry, this one would work in pneumatics. Are we okay? Okay. So these are some of the valves we have pneumatic-wise. So we have a two-way symbol. This is your on-off. This would be kind of like what's on the water fountain down there. It's either what? On or off. All right. So these are your on or off valves. So this would be the valve that's on your washing machine. This would be the valve that's on your ice maker. If you got an ice maker in your refrigerator, it's either what? It's either on or off. Then we come back and we add a return. So we have a three two-way valve. I don't know if we got any of those on the lines. We have a lot of 4 two-ways, and we have a lot of 5 two-ways. Can y'all see the difference between the 4 two-way and the 5 two-way? So here's the 5 two-way. So what happens is, if a 4 two-way, we would have one of them would have to exhaust. We'd only have one exhaust. So no matter which position you're in, so let's say this was exhaust, and then my exhaust is right here. Well, this port over here, this exhaust port would have to exhaust all the way out to the silencer here. This one would exhaust faster. So what would happen is it would extend. If you didn't have any flow control on it, it might extend faster than it retracts. What they do on a five-port valve is we have 2 exhausts. So that's the only difference. So no matter which way you go, it exhausts at the same speed. So these are your 5-port valves. So your 5-port valves have 2 exhausts. Your 4-port valves will have 1. That make sense? Are we okay? This is the one we just looked. This would be a 4 three-way. We add 2 exhausts. This would be a 5 three-way. This is what we use. This is what we need to use on pneumatics, by the way. So this would be a pressure port. So what happens is, when you're in the center position, you take the pressure and you put it on both. You take the pneumatic pressure and put it on both sides of the cylinder, and the cylinder won't move. So we have the ability to stop it in the center. Come on, I can see you thinking about this. No, just look at one of them. So 1, 2, 3, 4, 5. So that's what we got. So what happens is that when we're in the center position, and this is a double acting cylinder, this is pressure, so that's pressure. We're actually putting pressure on both sides of the cylinder. So what's going to happen? Wherever that sucker's at, it's going to do what? Stop. So this is what we have on the, they're simulating it on both the Festo and the Amatro line. I don't know why they didn't use one of these. So what they're doing, they're using two 3 valves, and they just put pressure on both. They turn both. We'll see it when we get there. So they're simulating these with 2 valves, but this would work perfect on pneumatics. This is called an open center. We probably wouldn't use, or some people call it a floating center. So if it's in the center position, you can grab that actuator and you can move it. Anything you want to do. So some people call that an open center or floating center because the actuator actually does what? Floats. We don't have any of these on our manufacturing line because we want to lock these cylinders in. So we have a lot of 4.2s and we have a lot of 5.2s, and we have a 5.3 closed center on the robot on the Festo line. We're simulating this, but they're using two 4.2-way valves. But they're simulating what we could do with one. So these are the valve symbols. Now, these all of them know hydraulics has a lot of them. They have a floating cylinder. They have all types. This is the ones that you would run to in pneumatics. The only ones we have on our lines is we have some of these. Where do we have those at? 2.2s? Y'all have used them already. 2.2s. They either off or on. No, these are manual. This is a manually operated valve. This is the disconnect on the pneumatics. That's that yellow thing. It's either what? It's either what? Off or on, right? So on the pneumatics, it's on there. I don't know of any 2.3s. I know we got a lot of 4.2s, and I know we got a lot of 5.2s. And the robot on the gripper on the Mitsubishi robot has a 4.3. And so that's the way they either lock the gripper open or lock the gripper closed. It would be better if they used one of these though, because you can still, if you grab it, even though it's open, you can actually move it a little bit because it's air, right? Right. So these are our operators. So this would probably be the operator on the disconnect. So operators are what you actually move the valve with. So manual operators, palm operators, push pull, pull buttons, hand lever. See some of these. Foot pedal, we don't have any of those, but this is real good. Direct solenoid, proportional or servo solenoid. This would be, you could actually control the spool. Motor operated, we don't have any of those. Cam operated, we don't have any of those. I never seen a stem. Spring return, we're definitely going to see these. By the way, the only difference between your symbols when we deal with pressure between hydraulics and pneumatics, so this is going to be the symbol for pressure. On hydraulics, it's going to be colored in, and pneumatics, the triangle's not going to be colored in. But all the symbols are the same. So you see this one, it's going to show up real good, but this one's colored in, so that means this is for what? Hydraulic. So this means it's pilot operated. Now what does that mean? Huh? Pilot operated means you bleed some of the pressure that's out there anyway, and you use the pressure that's there to shift the spool. So if you take the fluid power course, all the valves that we have over there are either manually operated or they're pilot operated. That bottom drawer one open. So this one, let me get up. This is a pilot operated valve. ports 1 and 5, these are 1 and 10. These are what actually shifts the spool. So when you look at it, the spool's on top, and you can actually see it's got this little guy right here. That's a directional control valve. Huh? 1 and 10, yeah. I don't know. I thought I looked at it. I probably might be wrong. Wouldn't be the first time. Yeah, it wouldn't be 1 because 1 is pressure. Yeah. So that's a pilot operated valve right there. So that means what we do is we actually use the air pressure, the fluid to shift the spool. Temperature operated, I've never seen that. This is primarily what we have, especially Festo. So what they do is they use the solenoid to open up a little valve that moves the spool. These are called a solenoid pilot operated valves. A lot of pneumatics will be done like this, even if they don't show you. Festo does a big old thing. It's a strange symbol, but I'll show y'all some of these symbols. So this is a hydraulic cylinder. So you can see there's no way it's a big directional control valve. And there's no way in the world a little solenoid can move that big old spool. So what the solenoid does, it opens up a little pilot valve. This comes around and moves the spool. We have one of these over there. We see these a lot in hydraulics, especially the higher the pressure you get up to. It's hard to get a solenoid to move that pressure. So what we do is we let the pressure move the spool. And these are called pilot assist, solenoid pilot operated. And this is really a good example. So you can see where it's actually, so it's got a valve up here. The solenoid moves a small valve. This takes the actual pressure coming in from the system and uses that to shift the spool. And we see this a lot in pneumatics. All the valves on the Festo line show the symbol, but the Amateur line might use them because it's transparent to you how it shifts the spool. All we know is the solenoid is either doing it itself or it's opening up a little pilot valve that causes it to shift. I was looking for mine, the one that came off the solenoids went out on the Festo line, and we had to order the whole thing. You couldn't just order the solenoid. So it was cheaper to order the whole valve than it was to order the solenoid. So I've got that somewhere, guys. I thought it was in my thing. And then when you take the solenoids out, you can actually see the little path that opens up to actually move the spool. So these are our valves. Everybody okay on these one direction flow control valves? Are we okay? So this is what we call a check valve. What does a check valve do? So how many check valves do you have? You got check valves. You got check valves. Where do you have check valves at? In your heart, right? Because your heart pumps, but how does it control the direction? Well, it closes one, opens the other, and they're like that, right? So you have check valves in there. You got one right here in your esophagus that keeps food from going down. Food you can throw up, but you can't do what gets into your airways, guys. So we got check valves. We got check valves on there. So it only lets fluid flow in one direction. So this is the way these things work, is that the way we do flow control, especially on flow control is hard to do on a single action cylinder. You have to meter first of all, you got to meter in because the exhaust is goes out the side of the cylinder, right? So what determines how fast it comes back is just whatever it does. But they're easier to control. But what we do on, of course, we do meter out. Everybody okay on meter out? What does that mean? We control the air or the fluid coming out. So if you want it, we can meter out hydraulics too. But hydraulics you can meter in or meter out. Pneumatics we like to meter out when we can, especially on double acting cylinders, because you're always pushing against the pressure. If you meter in, then your cylinder's going to be what? It's going to be jerky, right? Everybody okay? That makes sense? So you can see pressure comes in off our manifold. So we both the lines run manifolds except for one of our actuators, and then the cylinders, the valves mount on the manifold. Now, what's neat about the Festo is the manifold actually is on the side, and all your piping is done through the actual valves themselves. The Amatro line has a manifold on the bottom that's got the holes for the ports, and then the valves mount on top of the manifold, which you'll see more often. And of course, the size of your manifold would determine how many valves you can put out there. So all the solenoids is doing is pushing the spool, and what you got to imagine in your head is you got to see that whole thing do what? Shift. And it's going to be drawn in its off position, right? You understand? Oops. So let's see. So these are some valves. Unfortunately, all I got is one solenoid control valve. A manually control. All the rest of them are manually controlled valves. Our e-stop is a little different. So they've got an actual e-stop up there. So this is our manufacturing line. So we have our service unit with a pressure gauge. This one doesn't show the two-way valve though. So the Amatro's got that two-way valve out there, right? That we can the yellow thing that we use for disconnects. We have a pressure switch with an analog output, which is not in the PLC program, but that's the symbol for it. We have a pressure regulator. We have a variable pressure switch. So this is a switch where we can actually adjust when it trips. Everybody okay? No, this is on the Amatro line. And I think it's on Festo line too. This is a one-way adjustable flow control valve. Everybody okay on this symbol? Okay. Huh? Anytime. Yeah, anytime. And this is true on electronics, you know. So this is a symbol for a rheostat, which is a variable resistor. This is a symbol for a variable capacitor. This is a symbol for a variable power supply. So anytime on these things you see this arrow moving through them, it means it's variable. So a variable pressure regulator, that's this gray knob you pull out and you turn. By the way, most of the time you just can't turn a pressure regulator's knob because, so on most of them you have to pull up, then you turn them whatever pressure you want to regulate in, and then you snap them back in. And that's true on all ours. So what we can do is this guy right here is on the vacuum generator on the Amatro line, where it's got the suction cup that picks it up and moves it over. We have a little adjustment on there where we can determine where that thing trips. So if we turn it down too low, it'll drop the block, right? Or if we turn it down too low, it's not going to ever pick it up because it won't. We won't generate enough pressure. This is adjustable flow control. So you can see all they've done on a one way is they've combined an adjustable flow control with a check valve. This is the vacuum generator. We have both these on both the manufacturing line. So what this does is it takes a flow and converts it into a vacuum. So it's got to be moving, right? Suction cup, silencers, just about everybody called this a muffler. So you can see the silencers on the valve that we passed around. That I think these are ceramic, but they got a bunch of holes in them. So they're using either ceramic or copper. So here's the silencers right here. Technically, they're called silencers, but everybody usually calls them mufflers. And the silencers are going to be on the exhaust because that's where your exhaust is on your car, right? It's not on the input; it's on the output. Yeah. Huh? Drain the lines. Oh, air compressor. Then our valves, and one of them's missing, so we have a bunch of these. By the way, this is a manual operator, so you can manually operate these valves. So we can manually operate. Usually they're in huh? I tried to write manual, but it looks like Donald Trump's signature, right? I'm listening. No, that little thing right there means manual operated. Is that what you're talking about? Okay. That better? Yeah. So all our valves, even our relays, have manual overrides on them, especially on the Amatro line. Now, guys, you got to remember when you manually override something, you got to be really really careful, right? Because these guys are going to cause actuators to move. Those overrides, yeah. So they're usually not easy to get to. I'll show you on the Amatro line on both of them. Where you could actually manually, but they're usually indented, so you have to get something and push it down. You just can't do it with your finger like you can on a relay, which is dangerous. So this would be a what two-way valve, single solenoid activation, spring return with a manual override. That's the way we would nomenclature that. Are we okay? Yes, no. The bottom one would be a 4 2-way valve, double solenoid actuated, and a manual override. So we can manually override it in either direction. Man, this would be a quick exhaust. I don't know if anybody's using that. Depends on how far you're away from the main exhaust on your valve, or how far your valves are away. So normally your valve and your actuators are not close together. Well, what a quick exhaust does is we put that up by the actuator itself. And of course, you don't have any flow control here, but it basically exhausts real fast, and it would cause something to either extend real fast, or retract real fast. Questions? Okay, guys, y'all take a 10-minute break. I just added another. So this is Amatro Module 7. So that's not the one I want to show you. So this is, I'll come back to this one. Nope, this is the one I want. Okay, so this is a typical pneumatic circuit diagram. So we got 4 circuits, and I think we've already talked about this before, right? So normally a circuit will end with an actuator. So A, if we see A, it means actuator, right? B is what? Sensor. V is a valve, yeah. Uh, this is the two-way valve right here. This is the filter with a drain. So normally pneumatics, the filter is just a glass tube, and it shoots the air in. If there's any impurities, they're gonna be heavier than air, right? And they'll just fall into the glass. And you can look in there and see if it's got any garbage, and they just screw on. You can just screw them right out. Okay. This is a pressure regulator. What do you think this is? It's gauge. That's the same symbol we use for any type of gauge. What do you mean? Yeah, it does. It just air just go both ways. Yeah. And then this tells us it's what? It's variable. So on these, how do you adjust them? You pull the cap out and turn it. We usually run ours around 40, 60 or 50 psi. I think that the Festo, they recommended we run 50. The Amatro runs 60. We get around 200 psi out of our big compressor over there. So that regulator is regulating it down. What do you have to do? Pull the cap up, turn it where you want to, snap it back down. And that way somebody can't accidentally do what? Turn it. Unfortunately, you can't lock and tag it. So, or lock it. We was looking at some computers over in the drafting program where they actually had locks on it, so you couldn't pull the case off without the key. Uh, so M. So this M is what? So there's the M. What's the M? Solenoid. Yeah. I always spelled that wrong. Just whatever you want to say. Yeah. Solenoid. We usually just string it together. So this is the symbol. This is the true symbol for a solenoid. Is then we have a line through it like that. Now normally if it's pilot assist, they'll have another little symbol right here, and then they'll have that. Sometimes they leave that off because you don't know it anyway. But most pneumatic valves that I've seen are pilot assist, especially if you're running 60 psi and you're trying to move a spool against it with a little old tiny solenoid. Then all the solenoid does is open up a little pilot hole, and then it uses the full blown pressure to move the spool. So is it? I don't know. And of course, this is the manual operator, right? Manual override. So this would be, how would we nomenclature this? What would we say this valve was? 4, two-way, solenoid operated, spring return with a manual override. And you'd have to know that just to order it, right? Makes sense. So, and we talked about this. What's nice is that your actuators are given a number, and then all the components that control that actuator start with the same number. And then they number from bottom to top, left to right. So 1M1, well, we know right off the bat, no matter where it's at, it's controlling actuator 1, right? You understand? 1V1, well, that's the first valve controlling actuator number 1. 1V2, number left to right, bottom to top. It's the second valve, right? You understand that. Controlling 1V3, and then we have 1A. We've only got 2 sensors on here that's sensing when the rod is fully extended and when it's retracted. This means it's got a magnetic piston. That's what that thing means right there, right? It's got a magnet mounted on the piston, so these 1B1 or 1B2, it's got to be either Hall effect or it's got to be Reed. Actuator number 2 is a Ventura converts so it's not a true actuator, but since it's the last thing on the chain, they give it an A. It converts a flow into a vacuum. We can adjust it. It's got a adjustable pressure switch on it, or pressure sensor, excuse me, that we can set when it gives us a true or a false. And then it's got an analog pressure sensor, which would actually give us a voltage readout that would tell it that we can convert with either an indicator or with our PLC through a program if it's got an analog input. And it's hooked up, by the way. It's just not in the current programs. So this line is set up so you could rewrite the programs and bring all these analog stuff into play, but we haven't fooled around with it. Scared to, in fact. So then we move over to circuit number 3. It's got a 4 two-way valve with double solenoid actuator with manual overrides. It's got 2 one-way flow control valves that's set up to meter out, right? Then it runs up to a cylinder that's got a magnet on the piston so we can sense it. And that's okay with circuit number 3. Once you learn how to read them, it's pretty simple, right? Once you know these symbols, if you don't know the symbols. But what you got to imagine in your head is you got to imagine these valves actually shifting, right? Okay. Then actuator number 4, that's a rodless cylinder. Notice it does not have a rod. It's got a magnet on it. And it's using a 4 two-way valve, solenoid operated with manual override. Are we okay? That's the actual carriage that clamps onto the magnet. So if you look at this, what we have is there's a carriage that clamps onto this, and then it's going to do something. Yeah. Are we okay? Yeah, that's all it is. It's just a fixed rod, and it's got a big old hockey puck magnet in there. And then we just come up here, just like you said. I come up here and push that, and it causes the magnet to move down to one side, and we put it on that causes it moves back. And then what happened is the carriage, what's actually supporting the whatever we got on there, just clamps onto that magnet. You can actually break it loose on the lift on the Festo line. You can actually break the carriage loose, and then you got to get it recoupled, which is not easy, but we've had that happen before. No, you have to send it back with fluid power. So we got two. It don't automatically come back. We put pressure there. It causes it to move this way. We vent, we exhaust this side, or we come over, put pressure that, and exhaust that side. So it's just like a cylinder, except it don't have a rod. And somehow, this what we're trying to move with it latches on to that puck in the center. I've seen it, like I said, I've seen it had metal belts that come out and loop out, sealed up really good. Uh, and the big advantage of these is the biggest advantage of a rodless cylinder is the stroke. Is you can have these long strokes. So every one of the gantry crane that's on the right, it's a rodless cylinder. We got two on the Festool line. They could have done the lift. They could have done that with a regular cylinder because it's only got about that, probably about probably 9-10 inch stroke. But both those other robots, those have big old long strokes on them, and you're trying to stick a rod out that long, right? You understand? This is what's interesting. So these, by the way, this is the manifold. Y'all understand the manifold? What's the manifold do? Instead of us running pressure to all the valves, instead of us running an exhaust to all the valves are not individual, they're mounted on a manifold. And then they share the what? They share the pressure and they share the exhaust. So all these valves are mounted on a thing that's on the bottom. And then it's got the exhaust, it's got the pressure. It might have two exhausts on both ends if it's using those 5-port valves, right? You understand? And then it's got the holes up here with the working ports. And so the valves just mount onto the manifold. Now the Festool line, the manifold actually runs through the valves. So we have two end things, and this is where your pressure and your exhaust will be at. And then the valves actually just sandwich in between the two, which means now I'm not dedicated to buying a manifold that you can mount 4 valves on or 3 valves on or 2 valves on, right? You understand that? Here, basically, we can sandwich multiple between that. But the manifold actually runs through the valves, which is pretty interesting. So you'll see those things have got lines running all over the place. So this is a 4-2-way. This is a 4-2-way valve, and that's what I said. That's predominantly what we have is four 2-way valves. 4 2-way valves, solenoid operated, spring return, with a manual override. So what we do is we just energize one side. This is the pickup cylinder, so it'll drop down, and then we turn it off. It'll just go up by itself. The valve shifts by itself, right, when we turn it off. This one is a weird symbol because, it's the gripper. So this would be the actual gripper on the Traverse cylinder. So we turn this thing, so right now it's set up to retract. So we energize the solenoid, shifts to the left, the thing comes down, and then we turn it off, it automatically comes back up. So this is the gripper. So this is the cylinder inside the gripper. This is a single acting cylinder with a spring return. So this guy's got a brake on it. Now, what they're doing is they're using, these are not mounted on the manifold. We can show you actually where they're at. These are mounted on both sides of the mounts for the Traverse robot on the sorting station, station 7. But they're doing it like they're making it work like a 3-position valve. So when it's set like this comes to, bypasses, goes there, right? This has got a check valve. This comes through, bypasses, goes there, and this sucker's going to be locked. Now, it's pneumatics, which means we can move it a little bit. If it's hydraulics, you couldn't do anything with it. And then what we do is we leave one of them alone and we shift the other one, and it'll cause it to move one direction. We leave one alone and energize the other one, and it'll move the other. So it's acting like, and why they didn't do that, I don't know. It's acting like a three position. I'm running. Okay. It's acting like a three position valve with this guy that we drew a while ago. It's acting like they're using two of them to get this valve right here. So when it's in it, when they're turned off, it puts pressure on both sides of the cylinder. So each one of them's pushing against each other, and they don't want to move. Right? Understand? They could have done it with one valve with a pressure center, but they did it with two valves, doing exactly the same thing that valve right there would do. And they're using the same feature, by the way, on the Festo line. Then they reinforced it with a what? With a brake. So it's got a clamp on one side. You got to see where it goes. When this guy right here energizes, the clamp comes in and locks it. Then they put pressure on both sides, so that actuator is not going to move. So they reinforce it with a brake. Are we okay? Pretty cool. Festo does the same thing. So let's see, that's the same thing. This is a Festo print. Can y'all see these? Of course, you can barely see the little magnet symbol right there. But anybody know what that means? Anybody had fluid power? You know what that means? Huh? It's variable something. But anybody know? Fluid power. They should have covered this in fluid power. Normally, what we do on these cylinders, especially big hydraulic cylinders, and they're moving pretty fast, is we put a cushion in them. And basically, it's not a real cushion. What it is, it's a little pilot valve that when it gets close to the end, it can't vent, and it's got to go through the little pilot hole. And we call these variable cushions. And what these things are is just to keep the cylinder from slamming into the end caps. Yeah. So variable cushions. Yeah. So that's what that means. This is the hockey. This is the air hockey slant that when it turns on and so we can put a real narrow slant on that angle or that incline. And but I wanted to show you that. So anything else? Oh yeah, this does the same thing. They just do it in the opposite direction. So here's their check valves up here to keep it from bleeding back when we put pressure on both sides. But when this guy, so this is pilot assist. So they actually use that. They just do it real big. Solenoid operated pilot assist with a manual override. But it's still, and they use, this is very unusual. This is the first time I've ever seen this. So instead of using a spring, they're using air pressure to bring to shift the spool back. So it's, ain't that neat? So that's the first time ever. That's the first time. Huh? I don't know. It would surprise me. Yeah, this one uses it. I think say these are Festo valves. Festo actually got their start in pneumatics. I mean, they were a big hydraulic pneumatics company. They moved into, they call themselves dietetics, not dietetics. I got diabetic on my mind. But they got a name. It's their electronics section. They're really in automation now. But go ahead, James. Same one. Yeah, that would be over here, which would be pilot assist. But this is These are pilot returns. So instead of using a spring to shift it back to the, when y'all had to draw y'all, but they do the same thing. They lock it in position the same way. But here, instead of the check valves being down here, they got the check valves up there. So what they do here is they energize both these and shift them over and cause pressure to go here and pressure to go there, and it will lock it into position. We don't see that very often. It's just when we break the line apart, the Festo line, it's got two inclines where it can sort black, and red and silver, and so it's going to lock it in the center instead of having it move all the way to the end. But what they're trying to do is they're trying to simulate that guy with the pressure center, but they're using two valves to do that, which is pretty interesting. This is what they're on the gripper on the Festo line. All this is showing is that it's running through the piping through the robot. What would that be? Five port, because it's running 5 ports. It's running two exhausts, so it's 5 ports, right? And what's the exact advantage of two exhausts? They exhaust on both sides. That makes sense? So that means if you exhaust it on one side, then one of them is going to have to go a long way to get out. The fives. Now notice, pressure side is odd, working side is even. You understand? You understand, Jess? Yeah. And it's spring centered. So I mean, if I de-energize this guy and de-energize this guy, the spool is going to shift back to the center, which is that's the way all three position valves work, by the way. They just usually don't draw the spring. So closed center, which means if we put it in the center, the actuator is going to, the gripper is going to stay in whatever position it's going to try to stay. It's either going to try to stay closed or try to stay open. But it's pneumatic, which means you can probably move it a little bit because pneumatics will always compress a little bit, right? Because anytime you put it in motion, it tries to uncompress. If it was hydraulics, if you had a closed center like that in hydraulics, you would not be able to move it. Hydraulics, you're going to run into closed centers if they're going to use the pressure somewhere else. If they need to use the pressure somewhere else. If it's the only thing, they'll use what they call I can't remember what they call it, but they'll send it back to the tank. So guys, that's it for symbols and pneumatics. And like I said, these are not up there, but you have access to all these prints. Everybody understand that? All these diagrams. If you go into reference documents, you'll find. No, I don't. I think they're even. I mean, before I lie to you, let me make sure I put them up there. There ain't no telling how much space y'all's Blackboard site takes. I got all kinds of stuff up there. Of course, we don't host the Blackboard anymore. It's in the cloud. What happens when you turn the solenoid off? That magnetic field comes collapsing back into that coil and produces a voltage that you just wouldn't realize. Now, the problem we have with solid state devices is they have what we call breakover voltages, which means if you exceed the breakover voltages on one of your output ports on your PLC, you're going to blow the output port out. So this